A particle moving in a straight line pass through a fixed point O. Its velocity v t second after passing through O is given by v equal to 50 over 3t plus 2 square. So we can rewrite the v as 50 times 3t plus 2 to the power negative 2. Okay, find the velocity of the particle as it passed through O. So when t equal to 0, okay, so t equal to 0, then it's passed through O. Then the v will be 50 over 2 square. Okay, 12.5 meter per second. Okay, b, find the value of t when the velocity is 0.125. So when v equal to 0.125, so we have the 50 over 3t plus 2 square equal to 0.125. So we have the 50 over 0.125 equal to 3t plus 2 square. So 50 divided by 0.125, then is 400. Square root of 400 is 20. So we have the square root of 400 equal to the 3t plus 2. So plus minus. Then we have the 3t plus 2 equal to the plus minus 20. Then we have the 3t equal to 18, and then the 3t equal to negative 22, t equal to negative 22 over 3. This one rejected. And then we have the t equal to 6 seconds. Okay. C, find the acceleration when t equal to 1. So we know that acceleration is dv dt, first derivative of the v. So it will be 50 times negative 2, 3t plus 2 to the power negative 3 times 3. Okay, so it will be negative 300 over 3t plus 2 to the power 3. So when t equal to 1, a will be negative 300 over 5 to the power of 3. So 300 divided by 125 is 2.4, negative 2.4 meter per second square. Okay, that. Question number 2. A particle moving in a straight line passed through a fixed point O. Its velocity t second after passing through O is given by v equal to this. Find the initial velocity of the particle. So when t equal to 0, v will be 6e0 minus 2 times 0. So it will be 6 because e to the power 0 is 1. Okay. And then find the initial acceleration. So we know that the a is the dv dt. So we differentiate this will be 12e2t minus 2. So when t equal to 0, a will be 12e0 minus 2, then will be 12 minus 2, then it is 10 meter per second square. Okay. Question number. Particles start from rest and move in straight line so that t second after passing through a fixed point O, its velocity v is 5 times 1 minus e to the power negative t. Find the velocity of the particle when t equal to ln 100. So when t equal to ln 100, then the velocity will be 5 times 1 minus e to the power negative ln 100. Okay, and then it will be 5 times 1 minus e to the power ln 100 to the power negative 1. Okay, then it will be 1 minus 100 to the power negative 1. Okay, 0.99, 0.01. So 1 minus 0.01, then is 0.99. 5 times 0.99 is 4.95. Okay, meter per second. Okay. because the this one is 0.01, and then 1 minus this will be 0.99 times 5, then it's 0.4 4.95. Yeah. Okay, B, state the value which V approach at t become very large. So this one, we know that when the t become infinity, then the e to the power negative t is actually 1 over e to the power t, okay, will be 0. Okay, or we have the graph of this one is ex, and then we have the graph of the e to the power negative x. It's like this. So when the x approach to infinity, then the e to the power negative x will be 0. Or we have, like, we can try with the calculator e to the power negative x. So when we substitute with 100, then it's very small number already. If I have 1000, then it's 0. So it will approach to 0. Okay, so the v will be the 5 times 1 minus 0. Then it will be 5. Okay, find the acceleration when v equal to 4. Acceleration when v equal to 4. See here. Then we know that the a is dv dt. Then it will be 5 times e to the power negative t. Okay, so when v equal to 4, so when v equal to 4, then we have the 5 times 1 minus 1 over et is 4. Then we will have 1 minus 1 over e to the power t is 4 over 5. And then we have the 1 minus 4 over 5 is 1 over et. Okay, then this is 1 over 5. So this one is actually, this part is 1 over 5. So we have the et equal to 1 over 5. Et equal to 5. Okay, so 1 over 5 equal to 1 over et. Then the et, then we can compare this. So e to the power t equal to 5. T will be ln 5. So we ln both sides. Okay. So the A will be 5e negative ln 5. Then is 5 ln 5 to the power negative 1. So 5 times 5 to the power negative 1, which is 5 times 1 over 5, then is 1. Okay. So the answer will be 1. And then D, sketch the VT graph for the motion of the particles. 5 times 1 minus E. Okay. So D here, we know that this we can rewrite as 5 minus 5E minus T. So we know that the graph for e to the power negative t, this will be the e 5e negative t, and when we negative it, okay, then the graph will like this, negative 5e negative t, and then we plus 5, then if move upward 5 unit, and this is 5 is the asymptote. Okay, so we have the graph. Okay, so the graph will be something like this. Okay, then we have 5 here. Okay, so this is 5 here, this is v, this is t, so the graph will be something like this. Okay, uh, and then the VT graph. So when t equal to 0, then the V will be 5 minus 5 times e to the power 0, then it's 0. So the graph that I draw is wrong already. Okay, uh, it should be. So we know that when t equal to 0, it is 0. So the graph will be like this. Okay. And then we no need to draw the negative part. Okay. Because the negative part time will always greater than 0. Okay. So 5 times 1 minus e to the power negative t. So we use decimals. Then we have the 5 times 1 minus e to the power of negative x. Okay, uh, this is how the graph look like. Okay, and we have the y equal to 5 here is the asymptote. Okay, so this will be the graph. Okay, okay, the graph should look like this. A particle move in a straight line such that its displacement s meter from a fixed point O on the line at time t second is given by s equal to 9 ln 3t plus 2. Find the value of t when the displacement of the particle from O is 36. So when s equal to 36, then we have the 36 equal to the 9 times ln 3t plus 2. Okay, so 9, 4. So ln, then we will have the e to the power 4 is 3t plus 2. Then we can write the t as the e power 4 minus 2 over 3. Okay, and next, find the velocity when t equal to 1. So velocity is the first derivative of the displacement. So we differentiate this, then we will have the 9 times 1 over 3t plus 2 times 3. Then it will become 27 over 3t plus 2. So when t equal to 1, v equal to 27 over 3 plus 2, 5. So we have 5.4 meter per second. Okay. Show that the particle is decelerate. Okay. For all value of t. So deceleration. So acceleration. So we find the a, which is the first derivative of the velocity. So the v is actually 27 times 2t plus 2 to the power negative 1. So we differentiate this, then it will become negative 27 3t plus 2 to the power negative 2 times 2. Then we have negative 81 over 3t plus 2 squared. Okay, we know that the uh, 3t plus 2 square will always greater than 0. Okay, greater than 0. Okay, for the t greater than 0. Okay, when t is 0, then 2 square, 1, then 5 square. So this one will always greater than 0. So the 81 over the 3t plus 2 square will always greater than 0 also. But when we have the negative of 3t plus 2 square, it was always less than 0. So this will always less than 0. Then it is always decelerate. So the particle is decelerate for all value of t. So this is how we show. So the A is always less than 0. Okay. Negative, negative value. Okay. Question number 5. A particle moves in a straight line so that t second after passing through a fixed point O. Its displacement s meter from O is given by s equal to ln 1 plus 2t. A. Find the value of t when the velocity of the particle is 0.4. Okay, so velocity v equal to this. So we know that the v is the first derivative of the displacement. V is ds dt. So v is 2 times 1 over 2 plus 1 plus 2t. So it's 1 over 1 plus 2t and then multiply by 2. Then this will be the value. This will be the formula. So we have the 0.4. Okay, 0.4 is actually 2.5, 2 over 5. So 2 over 5 equal to 2 over 1 plus 2t. Then from here, we know that the 1 plus 2t equal to 5, 2t equal to 4, then t equal to 2 second. Okay. B. Find the distance traveled by the particle during the third second. So when t equal to 3, okay, s equal to ln 1 plus 2 times 3, then is ln 7. When t equal to 2, s is ln 1 plus 2 times 2, ln 5. So the distance traveled will be ln 7 minus ln 5. Okay. Then we can rewrite as the ln 7 over 5. Okay, we know that ln A minus ln B is ln A over B, meter. Okay, the unit is meter. Okay, just now this one is second. C, find the acceleration when t equal to 1.5. So we know that the acceleration is the first derivative of the velocity. So the velocity here we can rewrite as 2 times 1 plus 2t to the power negative 1. So the acceleration will be negative 2, 1 plus 2t to the power negative 2 times 2. So it's negative 4 over 1 plus 2t squared. So when t equal to 1.5, a equal to negative 4, 1 plus 2 times 1.5 squared. Okay, 4. This will be 4 squared. So it will become negative 1 over 4. So negative 1 over 4, which is negative 0.25 meter per second square. Okay.